Welcome to the Explainer. So, today we're going to dive into a piece of tech that's making AI smarter, way more accurate, and honestly, a whole lot more trustworthy. It's a bit of a mouthful, but it's called Retrieval Augmented Generation. You'll usually just hear it called RAG. And that is a fantastic question, right? It really gets to the heart of this huge challenge we have with AI today. You've probably seen this yourself. You ask a super powerful large language model a question, and what you get back is this answer that sounds so confident, so detailed, and it's just completely wrong. Well, that's exactly the problem that RAG is designed to fix. So why does this happen? Well, these errors, people in the field call them hallucinations, happen because these big models, like Gemini, are trained on this gigantic but ultimately fixed library of public info. Think of it like a textbook that was printed in 2022. Its knowledge just stops at a certain date, and it has absolutely no idea about your company's private documents or, what happened in the news yesterday. Okay, so how do we fix this? This is where RAG comes in, and the best way to think about it is like giving the AI an open book test. It's a really elegant two-step process. First, it goes and retrieves the relevant facts from a source that you provide. And then second, it uses only those facts to generate a reliable, grounded answer. All right, let's get into the nuts and bolts here. Before you can even ask your first question, the RAG system has to do some prep work. It needs to build its own specialized knowledge base. You can really just picture it creating this super organized, hyper-intelligent library, but made entirely out of your documents. So how does it build this library? Well, it all starts with ingesting your documents. First up, it takes all that text and breaks it down into smaller, more manageable chunks. And that's because, searching for a needle in 1,000 small haystacks is way faster than searching in one giant one. After that, it converts those chunks into a special numerical format and organizes them into this high-speed index, so it can find things almost instantly. Okay, now this next part, this is where the real magic happens. The whole system hinges on turning words into numbers. It uses a special model to take the semantic meaning of your text. I'm talking about the actual concepts and ideas behind the words, and it converts all of that into a numerical form called a vector embedding. And really, that's just a fancy way of saying a long list of numbers. And this slide shows that transformation perfectly. The phrase, the quick brown fox, stops being words and becomes this unique string of numbers, a vector. And here's the crucial part. Texts with similar meanings will end up with mathematically similar vectors. That is the key right there. It's what lets the AIs search for concepts, not just simple keywords. Now, this whole process isn't just one single piece of tech. It's really a team of powerful tools working together. You've got libraries from Google, for instance, that are amazing at creating those embeddings. Then you have specialized tools like LangChain that know how to intelligently split up the text. And then you bring in something like Face, which was developed by Facebook, to build that incredibly fast search index that makes the whole thing possible at a massive scale. Okay, so our smart library is built, it's indexed, it's ready to go. Now, what happens when you actually ask a question? This is where the quest for context really begins. Well, the first thing it does is pretty clever. It takes your question and runs it through the exact same embedding process we just talked about. It pulls the same trick, turning the meaning of your query into its own vector. Why? So it can compare your question's vector to all the vectors of the document chunks sitting in its library. And that comparison is called a vector similarity search. This is so important. It is not looking for matching keywords. It's doing something much smarter. It's looking for the chunks of text from your documents that are mathematically, and therefore semantically, closest in meaning to what you asked. And what's so cool about this is that it often boils down to something as simple as this one line of code. This is basically the engine of the entire retrieval step. It's just a command telling the search index, hey, take this question vector and find me the top 4 most relevant chunks from the entire library, and do it right now. It's incredibly powerful. All right, we've retrieved the clues. Now for the final and maybe most important step. Let's see how all this work builds towards an answer that you can actually trust. This is the augmented generation part of RAG. So here's what happens. The system doesn't just blindly send your question over to the AI. No way. Instead, it carefully bundles everything together. It takes those relevant text chunks it just found, that's our context, and packages them up with your original question. The whole thing becomes one single powerful prompt. And the most crucial part of that prompt is this instruction right here. It's a command that explicitly tells the large language model, look, I want you to act like a student taking an open book test. You must formulate an answer based only on the information I've just given you. Essentially, it's forbidden from just making stuff up from its general pre-trained knowledge. And that one constraint, it creates this night and day difference in the final answer. A standard LLM left to its own devices might guess or just give you a really generic answer. But a RAG-powered answer, it's going to be specific, it's going to be accurate, because it is grounded directly in the source documents that you provided.
Okay, this is all really cool from a tech perspective, right? But let's zoom out. Why does this actually matter? Why is RAG so important for the future of AI and how we all end up using it?
Well, it's a total game changer, and here's why. First, it just dramatically cuts down on those AI hallucinations. It also lets you build systems that can accurately answer questions about your own private data or about brand new information. What you're really doing is transforming a general-purpose AI into a specialized expert, one that's safer, way more truthful, and can even show you its work by citing its sources. Now, of course, it's not a perfect magic bullet. You can't just flip a switch. Making this work really well, especially at a massive scale, takes some careful engineering. For example, choosing the right size for your text chunks, that's a real balancing act. If they're too small, you lose important context. If they're too big, the search results get noisy and less precise. And yeah, scaling this from a handful of PDFs to millions of documents, that requires some pretty advanced systems. But look, even with those challenges, the reality is this. At its core, RAG is the #1 strategy we have today for building AI applications that we can actually genuinely trust. And all of this leaves us with a really interesting final thought. As this technology gets better and better, and it will, the real power isn't just going to be in the AI model itself. It's going to be in the quality, the depth, and the scope of the knowledge that we choose to give it. Suddenly, the person who curates the library becomes just as important, if not more important, than the AI librarian itself.